This video, we're going to look at a few problems here that involve units of power, energy, density, some things that are not just our typical units that we've been dealing with, length and volume and area and so on. So we're going to deal with these other units. So 14 gram object. This is its mass, and its volume is 35 cubic centimeters. So its density, which we use a kind of crazy looking P thing, it's a Greek letter rho, stands for density, is going to be equal to the mass per unit volume. So my density here is going to be 14 grams divided by 35 cubic centimeters, and we're going to change that into a decimal here. (14) divided by 35 is 4/10, and the unit is grams per cubic centimeter, or we can write that as 4/10 grams per milliliter, because a cubic centimeter is the same thing as a milliliter. Next thing that we want to talk about is power, which is kilowatt hours here. So P is equal to IE that, but let's not worry about that. Let's just deal with the cost of lighting a 500 watt outdoor light for 8 hours. So we want 500 watts times 8 hours times 7.5 cents per kilowatt hour. So the watts right here, we need to change to kilowatts. So we're going to have to multiply by 1,000 watts per kilowatt. Watts will go away. Hours are going to go away. Kilowatts are going to go away. And I'm going to be left with 500 is going to go into 1,000 2 times. 2 goes into 8 4 times. 7.5 times 4. It's 20. 28 and 2 is 30. So this is going to be 30 cents. Land has an area of 420,000 square miles and holds a population of 65.6 million people. And we want to express that as a concentration, as a population density, people per square mile. So we're going to divide here. 65.6 times 10 to the 6th, second EE 6, that's times 10 to the power of 6, because that's millions, divided by 420,000, like so, is, and we're going to round to just a couple decimal points here, 156.19 people per square mile. A 12-ounce can of beer has about 15 grams of alcohol. Consider a person who has approximately 6 liters or 6,000 milliliters of blood, who quickly drank 2 cans of beer. So they drank roughly 30 grams of alcohol. The alcohol were immediately absorbed into the bloodstream, which it's not, but just pretend it is. What alcohol content would we find? So we would have 30 grams of alcohol in 6,000 milliliters of blood, and one divided by 200 is 0.5%. So grams per milliliter. So if you wanted to change that to a blood alcohol concentration, you could see that that's probably what they are talking about with BAC. And there you go. So your electric bill states it used 770 kilowatt hours in January. Determine your total electrical usage in joules. Give me a second and I'll give you that formula. So 1 watt is equal to 1 joule per second. So we're going to use that here to say that this is 770,000 watts times 1 hour times 1 hour is 3,600 seconds. And we're going to replace the watts there with joules per second times 3,600 seconds, and the seconds will go away. And this is going to be probably something that we're going to call megajoules, probably, but let's see. So we've got 770,000 times 3,600 is all right. So that's a big number, and usually no one's going to talk in numbers that are in billions like that, but it did ask us to answer in joules, so we will. Let's talk about how we would normally answer that using a bigger unit here. So this is going to be kilojoules, and this is going to be bigger than kilo is mega. So usually megajoules is what we talk about when we're talking about energy usage for a house. So this is 2,772 megajoules, like that. I really could say that this is 2.772 gigajoules if I wanted to. Just remember your prefixes for your metric system, and it'll make sense what I'm saying there, that I could say that 2,772 megajoules is the same thing as 2,772,000,000 joules is the same thing as 2.772 gigajoules. All those are the same thing, right? Your electric bill states that you used 840 kilowatt hours of energy in September. Determine your average power use in watts. So we're going to change this to hours. So we need to know that 1 kilowatt hour is equal to 3.6 million joules. That's going to help us here in a second. So we're going to get rid of our kilowatt hours. And I'm going to make this 3.6 times 10 to the 6th joules. And that's going to go away. So open up my calculator. 840 times 3.6 is 3024 times 10 to the 6th joules. And remember that joules are watts in 1 watt per second, right? I'm sorry, watts are 1 watt is equal to 1 joule per second. Sorry, there we go. So let's figure out how many seconds were in the month of September. 30 days has September, April, June, and November, right? 30 days times 24 hours in 1 day times 3,600 seconds in an hour is going to be 30 times 24 times 3,600. Want to divide that by 2592000. seconds. And this is going to be a big number, 3024. Not a big number, but big numbers to type in. 2, 3, 4, 5, 6 divided by 2592000, and I get 1166.67 watts. That's what I get. There we go. They wanted it to 1 decimal place, so 0.7. There we go. Let's clear our canvas. Do just a couple more problems. An object has a total volume of 3 liters, which is 3,000 cubic centimeters, and a mass of 2 kilograms. Find its density, and then decide whether it will sink or float in water. So its density in grams is going to be 2,000 grams. Its volume in cubic centimeters is going to be 3,000 cubic centimeters. So its density is going to be 2/3, or we can say that it's about 0.67 grams per cubic centimeter. That's exactly 2/3 because the density is less than 1. It will float in water. Water has a density of 1, so things that are less dense than water float. Things that are more dense than water sink. So density here is going to be exactly 2/3 of a gram per cubic centimeter, which is about 0.67 grams per cubic centimeter, and that means that it's going to float. You burn 900 calories when exercising for 35 minutes. What is your average power when exercising in watts? So 900 big C calories are kilocalories. They're food calories there when exercising for 35 minutes. So we need to change calories per minute to joules per second so that we can get them equal to watts. So, second. All right, so there's the conversion factor. I just wrote it down right there that 1 food calorie is 4,184 joules. So we're going to use our method of dimensional analysis that we've been using in this chapter. Say 1 calorie is 4,184 joules times, and we need to get seconds in the denominator. So 1 minute is 60 seconds. Let's go ahead and let's see if we can get rid of anything here. Divide by 10. 3 goes into here 2 times, and into there 30 times, and 2 goes into there 15 times, 5 in here 3 times, and then there 7 times. So we're left with 3 times 4, 8, 4 divided by 7 Calories will cancel. Minutes will cancel. I'll be left with joules per second, which is watts. Three times 4184 is 12,552 over 7. Is 793.1. And that's my right answer. So there you go. I hope those help you see the difference between power and energy and some units of concentration like density and things like that that we're going to use, not just things like mass and volume and area and all those things that we've been talking about, but there's other units that you're going to need to know how to work with in the real world. All right, see you for our next video.